Okay, so let's get going with actually pathing the part. Alright, so we're going to go to File, I'm going to add some geometry. So we're going to load the geometry file first. So we saved that on the desktop in cutting demo, and that's the model that we saved. And we've got the two curves, so I'm going to bring in the model first. Okay, we can have a look at where the model is. Make sure it's in there and it all looks good. And then I'm also going to bring in the outside curve, and you'll understand why in a minute. So I'm going to load the outside vector file, one for roughing. And what that does for us in many cases, when you bring in just the geometry on its own and you then bring in a cutting curve afterwards, sometimes your supports are not going to be in the same position as your outside cutting curve, and the default cutting window is not big enough, and then you have to go in and edit and create the window a little bigger. So always bring in an outside cutting curve anyway, so that it expands the size of the cutting window for us to the size of the outside curve I intend to cut with. So we've got the geometry in there that we want to start working with. This video will be in two parts. I'm going to do just the roughing for now. So I'm going to go up to the part. I'm going to rename that. You can click twice the same as you do in Windows softly. So I'm going to go roughing 317 ball end mill. Now this will actually be written into the code. So if you ever have to open and edit the code manually, it's easier to know what you were doing than try and have a guess what tool you were working with. So you've got two things. The one up the top here sets up the geometry for you, and this one actually produces the cutting. So we're going to have a look at the geometry setup first. And you can see that we've got a name for it inside here. Do we want to transform the model at all? No. So if you wanted to scale it, move it, mirror it, do that kind of stuff, this is probably where you'd be doing it in the transform. I do all of that in Rhino before I bring the model in, so not an issue. It does become relevant once you want to start turning the part around for doing multi-axis cutting on 4 or 5 axis. Material, I'm using all the CAD data, or you can set graphically inside of here saying that I've actually got a bigger block that I'm cutting this from, and there's multiple pieces I want to cut. In your case, in my case, most of the time you're never going to change that. What you will be changing is the 0 point. Okay. Now you'll recall from the previous video I said under the options menu you can set your defaults. Now the default over here is to make the center of my block in X and Y the center of cutting. So in other words, 0 is here in X and Y is here. So moving in this direction you're going into negative X and negative Y, going that way, and then positive this way and positive this way. It just means that when you set your datums on the milling machine to 0, it expects that this model will actually come into Mach 3 with that datum set to 0 over there. All coordinates will have negatives and positives from that. Now, many milling machines or operators who only work in 3-axis, they use a datum at this corner. So in other words, this is X and Y 0, and Y will go positive in that direction, and X will go positive in that direction, and anything underneath this is 0. So that's just, it's a legacy thing, and some machinists prefer to work that way, especially if you're only working in 3-axis, because it means you can bring your cutter to the bottom left corner of the material, and you know that you're cutting in that direction. Think of it like a laser machine would probably use that kind of setup. So I'm happy to leave that where it is. Now our problem is going to be, where is Z? Now because majority of the time I cut stuff on a rotary axis, the rotary axis pointing along X, okay, it means that this part's going to rotate around, and my wax is clamped up in the center of the rotary axis, so I need the center of my part to be in the middle. So in other words, Z0 in this part is through the middle of that pip roughly over there, because I want even amounts of wax on either side, or wood on either side if you're cutting a rotary part. In our case, we're going to be locking down this model onto the milling machine from a larger block of wood in this case. We're going to be using a bolt to hold the wood straight down onto the face of the 3-axis face, and I want to start cutting from the top down. So I'm going to need the top of the block to be 0. Alright, the reason for that is because I'm going to bring a cut down to the top of the wood, and I'm going to set the cutter to 0 at the top of the wood, and I want to cut down underneath 0 to cut all of this away. Alright, so in this case, the only thing I'm changing in that menu is I'm going to make the top of the block 0 and I'm going to click apply and OK, and you will see that okay, and you will see that what will happen now is the cutter will come down to the very top of this block. I'll zero it out in Mac, and everything will be cut under there, and the datum for X and Y0 is now in the middle of the cross. Okay, now we're going to go to the actual geometry location, and I'm going to set this up for roughing. Okay, I'm going to call it roughing so I can remember, because I Control C, Control V a lot of these operations, I forget what they were. Now in this case we're going to use that ball end that I was talking about. So we're going to go through our tool library, and I just created it. Where did I create it? I created it. There it is. Alright. Now the distance between toolpaths and the step size along toolpath is how far, I'm going to cut in a raster, so the cut is going to move back and forward like this. Alright, so how many millimeters or microns is going to move in between passes? So the cut is going to move left to right, it's going to move forward, in this case 0.6 millimeters, and then it's going to come cut the next pass, and then move forward 0.6 millimeters and cut the next pass. So this is your resolution, if you will, of this cut. In the case of a roughing cut, not too important that it has to be super fine, but you do have to watch your tools. So I try to never go more than 20 or 30% of the diameter of the tool, because you can break tools. In wood it's unlikely, but I'm going to play it safe in this case anyway. So DeskProto makes it a little bit easier for you. You've got diameter divided by, so that's a third of the cutting tool, and that's about 20% of the cutting tool over there. Alright, diameter divided by 5. So I'm going to put on there. And then step size along toolpath is similar. It's when I come along here and I move up over the model, how many millimeters do I move across the model before I take the next datum point? Alright, so there are reasons you can want this different to the distance along toolpaths, but generally speaking I'm going to set those two to the same thing. Okay. It gets a lot more important once you get into actual finishing cuts where you're cutting directly to the model. In this case we're roughing, and we're going to leave a little bit of skin. My spindle speed in this case in wood, this is quite a complex topic, I'll cover it in a separate video. It's 9,000 RPM, and I'm going to cut this path at a feed rate of 400 millimeters a minute. Okay. Now, like I said, a separate video on this. Every kind of tool, whether it's carbide, high-speed steel, every kind of material, wood, aluminium, wax, there's a different mathematics that works for this. There are online calculators for that. I'll pass you a few of the links for that. Alright, so we've set up what tool we're going to use and the speed we're going to use the tool at. We're going to move through to, and remembering that if this is what you cut all the time, you can set it in the options default part parameters. So every time you open this menu, it defaults to this, assuming that's what you do. Strategy. And now this is showing you that you're going to cut parallel to the axis. So I'm going to cut a line, 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 and move my way across the model. Crosswise, same thing. It's going to cut a line across the model, then come back and cut more lines like that, and then block is going to cut through that. Circulars, just look at the pictures, it'll kind of show you what you're cutting. And again, for every kind of model, some of these may be more important than others. Alright, the last little one, contour only, we'll get to at the very end of this video. But for now, you can just pick parallel. Now, depending on your milling machine and again your model, if you had a model with, example, a lot of V grooves traveling in this direction, you'd probably want to pick an angle that matched the direction of the V grooves. In the case of this model, it's pretty much geometry in every single direction, so I'm just going to stick with along the x-axis. I could rotate this to turn to cut that way or this way, whichever way you want. This is where you would do that. Now this is kind of, your jewelry background will help you with this. You'll know that if I was cutting this with an engraver, what's going to be the path of least resistance for my engraver? Would I travel in that direction? Would I travel in this direction? So that's kind of what this menu is about, right? Now roughing, I'm going to, in wax, I'd cut this all the way down in one shot because it's very low load on the cutter. If you try to do this in wood or metal, completely different story. And again, that math from the first thing is worked over here. So the depth of cut, DOC, you'll see it referred to a lot, is how far down can the cutter cut into the material before I'm risking breaking the cutter. Now, if you worked in the first menu and you set your speeds a lot slower, you could probably get away with a lot deeper depth of cut. Now, if I left this layer height on cutting length of the cutter, cutting length of this cutter is 15 millimeters. It would try to jam the cutter down all the way to the bottom and then start moving across the model. Likelihood is you're going to dislodge the model from the tabletop and or break the cutter and or both. All right, so I always work on my maximum depth of cut is 1/2 to 1 times the length of the cutter in very hard materials, or 2 times the length of the cutter in softer materials like the wood. I'm going to, just to play it safe, this is a 3.17 millimeter cutter. I'm going to stick it in about half of that. I'm going to say 2 millimeters. So it's going to cut a bunch of passes. So it'll cut the first pass and then move down 2 millimeters, cut the next pass, move down 2 millimeters, cut the next pass, until it gets to the bottom of the model. All right. The skin thickness that we're going to leave on this, because this is a roughing pass, do I want to cut right down to the model? No, I want to leave a little bit of material above the model, so kind of like shrink wrapping a little level of material over the model to ensure that when we go in with this big cutter, we don't actually hit the model anywhere. What we're doing with the roughing pass is we're removing as much as possible of the material with the big tool that can do it easily, so that when we go in with the small tool, we don't have to struggle with all these lengths over here. We can go in and do a final cut right down to the bone. It means the smaller tool can move a lot faster without risking breaking. So I'm going to put in, I don't know, I guess say 0.3 millimeter skin inside there. If you're in metal, this is very important, your ramping angle. You don't want to jam a tool straight down into metal and start moving it. Likelihood of cutting is very high, because as the first time the cutter goes into the material, there is 100% load on it on every face, on the side faces, on the front face, in every direction. That's a very risky scenario. So what ramping angle does, it will bring in the tool at a very slight angle and then bring it back at a slight angle to allow the cutter to absorb the initial impact of entering the material. After the cutter starts moving, that impact is on one cutting face, the direction of movement, and possibly the down face at one time. For you and I, this is not too important. It depends on how rough you cut. All right, so this is setting up for the roughing. We're going to move over to the area. Now, this is why we brought in the curve. We're going to bring it in again. All right, where do I want to cut? What's the area I want to cut? Now, you could use the entire area. Let's say you had a big block of wood inside here, and just say cut. It would cut everything inside this orange box, and it would exit this block out. You would see a hollow into the wood with the cross sticking up proud, and that's a perfectly valid way to cut as well. For me, I always use a curve because every extra movement is more time on the milling machine. So if you're sitting cutting out this area here for nothing, and you didn't need to cut it out, it's a pointless exercise. So I go in and I set it freeform. Now you can, whoopsie. Let me bring that in. Now you can, in this menu, you remember when I was in the Rhino menu, I was saying to you, let's have a look at why I bring curves in. You can, in DeskProto, create a curve and draw where you want to cut, but you're kind of doing that freehand, and it's not going to be as neat because the vectors are line vectors, they aren't smooth NURB vectors. So we do know that we pre-created a file. I'm going to import it, and it was my roughing. So it's in there, and I'm going to click OK. Alright, now how far down do I want to cut on this? The model is 7 or 8 millimeters deep, I think, something like that. But I'm going to just put this on for now. Let's have a look. Alright, so it's now going to cut everything only inside that. If I apply that, you'll see that you now got a green line saying that I'm cutting everything inside of the green line only. So it's ignoring everything outside of the green line. We're going to come back and play with this in a minute. Borders, do I want to allow extra for the border? Alright, so in other words, if you were cutting this block, would you want it to move just the diameter of the cutter outside of the green line, yes or no? I always go no extra. So you can play with these two. Cutter stays within the area. So in other words, the cutter would cut up to the line and not around it. No extra means the center of the cutter is on the green line. And then of course extra is the cutter is the outside of the green line. I'm just going to leave that on no extra for now. And then let's have a look at the movement. Now meander is, you know that we're cutting, we picked a strategy that's going to move the cutter along the axis, and in actual fact what we picked was it's going to move and then it's going to come all the way back, and then it's going to move again, and it's going to come all the way back, and it's going to move again, and it's going to come all the way back, and all of those are going to happen with the cutter's going to come down into the material, cut across the material, pick up, move back, come down, move back. Now meander is the opposite of that. What I just described is conventional, and I think it defaults to conventional. I've set my settings to meander, which means that the cut is going to go down into the material, cut across, move up, and then it's going to cut backwards across the material. Then it's going to go up and then move forwards across the material. Now why this is important in some materials, some woods, and even some plastics, the rotation direction of the cutter wants to cut uphill. So in other words, the cutter is moving in this direction and the cutter is rotating in that direction, and you want the cut to go cut into the material, versus the cutter is rotating in this direction and the cutter is coming backwards, so it's running downhill, and it can leave bad surfaces on some materials. So that's why you would pick between those two. Free movement height is how high above the top of the material should the cutter come up and move away from the material to come down. Now there can be reasons for that. Perhaps you've got a bolt inside here and you're worried that, holding down the wood like we are, and you're worried that the cutter is going to come out and run into the bolt or the fixture on the mill table, and you give yourself a little bit of play over there. In this case, I know that the bolt's going to be out here, so I'm just going to go stay low for this one. Different materials, if the cutter detects that it's moving down very fast, or it's moving through a lot more material than, like out here it's cutting not a lot, but suddenly it dips down, can you allow DeskProto to reduce the feed rates? In other words, slow down the machine as it's taking deeper cuts and then speed it back up when it's not taking as deep cuts. Now, as we're roughing, in both cases, doesn't really matter what I put in over here. Now, sorting is, in the case of a raster cut like we're doing, is not that important, but if you were doing cuts, profile cuts, where you're going down in Z over the face, and you're going down over the sword, and then you're going down over this, and you're picking from the highest to the lowest, should DeskProto automatically sort these things so that when he cuts the face, it comes to the plate instead of moving to the next highest part over here, which is this part. So it buys you a little bit of time in the amount of random movements the machine's moving. All right. In the advanced menu, do we want to skip ambient? Now ambient is, there are gaps in the model. So in other words, if this cross had a hole in the middle of the model, do we want to cut them? This would be machine all. We want to cut through all the ambient, or we want to just, if there was a hole, imagine there was a big hole in the middle of this cross, sitting there cutting all that big hole is pointless, because if you came in and you cut to the edge of the hole and then came over and cut to the edge of the hole there, by the time you finish cutting, the majority of the hole would fall out. Now in wood and wax, doesn't really matter, but in hard materials where the machine's moving really slow, skipping that ambient would save you a lot of cutting time. In our case, doesn't really matter. All right. When we do the 4-axis example, I'll take you through the extra NC commands over here. They're about what should the machine do before and after it's finished cutting. Okay, for this demo, we don't need to play around in there too much. I use it primarily for chaining operations, where I'm going to do one cut and then another cut, rotate the axis, maybe rotate the 5th axis. This is where you would tell those axes to move. All right, so I'm going to apply all of this, and I'm going to rotate and just do a quick little test of the path. So that's the little right path. You can see the little tool cutter with the red, and we're going to generate it and have a look what it did. Okay, so you can see that it's coming down in those Z levels that we asked for. So it's cutting down the top of the material by 2 mm, coming back down, back down, back down, back down, back down. All right, And it's coming in a little bit low for my liking over here, so I've got to make sure I've got enough material inside there to do it. If you were a smart guy, you'd measure the height of that, divide it into maybe 6 steps, and then put the exact step depth into the depth of cut down. But for now, for the wood, I'm not too bothered about this. So I like to inspect the paths just to make sure the machine's not doing anything stupid. I've yet to see DeskProto do something stupid, but you never know. Maybe you forgot a setting in there somewhere. This would be the time that you'd see I'm having problems. Okay, so look for any crazy movements, too many movements upwards. In this case, everything looks okay. You can tell from the little up and arrow, this is where the cutter is expecting to come in, and it's moving kind of across the model like that. And the final movement of the cutter would be over there. Now, I think that's good, and I'm going to save that path out. So I'm going to write that path, which is this little button over there, and I'm going to manually inspect the path. Okay. Now, that little thing I was just discussing, I see Lex has put a warning inside there. It is warning me that I've gone below the bottom of the model a little bit. I'm okay with that. I'm going to put a piece of wood in here that's way thicker than that anyhow. Now, I'm going to save that as roughing. Now, when I save the file, I also put the name of the cutter in the file. At all times, as far as you can, remember to do that. It just saves you a lot of time and headache once you leave your work machine and you go back to the mill machine on which path was which path. Alright, I'm going to save that out, and then we're going to have a look at. We're actually going to have a look at the file itself. Now, if you don't have already, I'd recommend installing Notepad++. It's free from the web and it works a lot better than Notepad. And then those are the actual G codes that are being produced to cut the part. Now, I'll do a separate video on G code and what all these commands mean. But essentially, you've got to turn the spindle on at a RPM of 9,000, move X to 20.161, Y to negative, and then Z to 5.3 mil above the top of the part, and then move Z down at a feed rate of 400, and then move Z down again 2 millimeters at a rate of 300 mil a minute, and then start moving XY, XY, XY. So let's do the finishing pass and we'll go out to the machine.